Good afternoon. So here we are supposed to study about the maximum power transfer theorem. Maximum power transfer theorem tells that maximum power will get transferred to the load when the value of load resistance that will be equal to Thevenin equivalent resistance. It means what? If we will get RTH and RL equal at that time, you can see here we are drawing here graph which will be power with respect to load, and if we are having the value of load resistance that will be equal to RTH. So here if we are driving the value of RL and RTH is becoming equal to RL, we can say we will get the maximum power, we will get the peak power. So we are saying maximum power is transferred to the load when the value of load resistance equals the Thevenin resistance as seen the load. So sometimes there is necessary to determine the load impedance that is connected across two terminal of the circuit. So maximum power will get transferred to the load. For example, if we are having any circuit that is consist of impedances, energy sources, where we will see variable load is connected at the output. At that time, if we are supposed to derive the maximum power, at that time, you will get that maximum power value by using the maximum power theorem, and maximum power states that maximum power will get transferred to the load if the value of load resistance will become equal to Thevenin equivalent resistance. So if we are having any DC network which will consist of only DC source and the impedances, it means what? Resistances. So if there is no active element, like there is no reactive element like inductor and capacitor is present, only there is a presence of energy source and there is a presence of resistance. At that time we can say load maximum that will be ZL. Now load ZL will be purely resistive because we are saying if a network which is consist of only DC source and a resistor, at that time according to the Thevenin theorem we can replace our circuit by using the open circuit voltage and resistance that will be in series with that voltage. But here, if we are supposed to calculate the maximum power, at that time, maximum power theorem states that maximum power will get transferred to the load if the value of RL equals the RTH. So here, if you see, when we are having any circuit, at that time, when we are converting that circuit into a Thevenin equivalent circuit. Thevenin equivalent means what? Here we can say that voltage as a Thevenin voltage. Here if you see the value of Thevenin resistance is in the series with that RTH, is in series with the Thevenin voltage. If there is load given at that time, you can take that load at the output directly. If there is no load given at that time, you can take VOC RTH because that voltage will be a open circuit voltage. So here any linear complicated network we can convert into a Thevenin equivalent circuit where we will get voltage that will be in series with the resistance. So when you calculate the value of RTH, and if the value of Thevenin equivalent resistance is equal to the RL, at that time you are saying maximum power will get transferred. So how to derive power? We know power is nothing but I square RL because we are having the formula for power V into I. So you can write I R into I. So your equation will become I square RL. So you can write that equation as I को तुम क्या करोगे? RL you will write as it is. RL you can put here as it is. So here when you are supposed to draw about, just wait for a minute. You can write that equation as VTS square upon RTH plus RL into RL. So here we can say maximum power will get transferred to the load when the value of RTH will equal to the RL. So here if we are having the equations P equal to I square RL, VTS square upon RTH plus RL into RL at that time. If you are deriving the derivative of power with respect to the load resistance, you can calculate this equation in the form of U by V. Derivative of U by V. You can derive like U square derivative of V minus V square derivative of U. Means you can take U into derivative of dV by dt minus V du by dt upon V square. If you are writing like this, you will get the value of dP by RL equal to like RL equal to RTH. So we can say the value of power that will be transferred to the load will be maximum if the value of RL equal to the RTH. So if you are writing the value of RTH in this equation, your equation will become V square. RTH plus RL both are having the same value. So you can write RTH. So your equation will become P max equal to VTH square upon 4 RTH. So you can derive the value of maximum power. So here we are supposed to solve some numericals by using the maximum power transfer theorem, because you guys have requested to see the numericals, to study the numericals. That's why we are taking this extra lecture to derive how we will get the maximum power in these network functions. So here if we are supposed to find the value of RL to get maximum power in the given network, and we are supposed to find power also. So what we can do, we can convert this network into a Thevenin network. How we can convert? Because we know if the value of RL and RTH are equal, at that time only that power will get maximum across the world. So here if we are supposed to calculate the value, that network we are supposed to convert into a Thevenin at that time. Firstly, we are supposed to calculate the value of Thevenin equivalent resistance. How we can derive? If there is a current given, at that time we can make that current as a open circuit. And if there is a voltage source given, same circuit मैंने फिर से ड्रॉ किया है. ये डेरिवेशंस ये सब ऑलरेडी हम देख चुके हैं. ओनली वी आर सपोज टू सॉल्व द न्यूमेरिकल. सो यू गाइज कैन सी हियर, इफ वी आर हैविंग एनी linear network at that time, we can convert that network into a simple network where we will get only one voltage and one Thevenin resistance that will be in series with that voltage. So how we can convert? If there is a voltage source, we can take that voltage source as a short circuit. We can take directly as a wire. And if there is a current source, we can make it is a open circuit. यहाँ पे दोनों वायर ओपन रहेंगे, तो तुम ड्रॉ करो ना ड्रॉ करो, it is having the same meaning. So here, when we are supposed to calculate the value of Thevenin equivalent, you can see here, if we are taking this 2 ampere as open circuit, तो ये नोड नहीं रहेगा, because यहाँ पे दो ही कंपोनेंट रहेंगे. This will be in the series. See, if these 2 and 3 in series, so we can calculate that 2 and 3 that are in series. So 2 plus 3, that will be 5 ohm. So here again, if you are supposed to calculate the value of Thevenin equivalent resistance, how we can see? We can see that's 2 and 3 plus 2 and 3. These are in the series. So you will get 5. And if you see for the 6 and 12, these are in the parallel. So you can take 6 into 12 upon 6 plus 12. That will be the resistance for this. If you are not supposed to see, you can see here. How we will get? Here we are supposed to find the value of Thevenin equivalent. So here, if you see, these 6 and 12 are in parallel. So you can calculate 6 into 12 upon 6 plus 12, that will be 18. So 6 into 12 divided by 18 plus 5. So you will get the value of Thevenin equivalent resistance, that will be 5 ohm. That will be 9 ohm. Sorry, 5 nahi, 9 ohm. So you will get value of maximum power, that will be 9 ohm. So now we are supposed to see here, we are supposed to calculate the value of power, because there is a question, you are supposed to find the value of RL. You are supposed to find the value of maximum power. So here RTS draw कर लिया है, तो RL का value same रहेगा, that will be 9 ohm. Now we are supposed to derive the value of power. For that, you will be needed the value of Thevenin voltage. So how we can derive? You can derive by any method. You can use node analysis, you can use mesh analysis, you can use Thevenin network theorem, any method, and you will get the value of Thevenin voltage. If you are applying here KVL to these two loops, your equation for first loop will become, if you are taking clockwise directions, clockwise, that 12 volt will go from minus to positive. So you can take minus 12 plus 12 plus 16, that will be 18 I1. But for 12, I2 is outgoing, I1 is incoming, so we are taking it is as a positive. I have directly written for 12 and 6. तुम 12 I1 plus 6 I1 लिख सकते हो. I have written directly 18 I1. But I2 is outgoing, so you can take minus 12 I2, or in another language you can write minus 12 plus 6 I1 plus 12 I1 minus bracket में I2. If you are writing, you will get the same equations equal to 0, because when you are applying KVL to any loop, the summation of algebraic summation of potential difference for each and every element across closed loop will be equal to 0. So here, if you solve that equation with respect to 0, you will get value of I2 current, that will be minus 2 ampere. How will you get? Because if you are applying here KVL to the second law, KVL to the second loop, not law. If you are applying KVL to the second loop, our equation will become here. When you are applying KVL to the second loop, you can see here we are having the value of current directly. So here you will get minus 12. Here 18I you can write as 6I1 plus 3I2 plus 2 into 0 plus VTH. That will be equal to 0. So you will get value of VTH, that will be equal to 22 volt. If you are applying KVL to this loop, our equation will become 3I2. 3I2, you can see here, 3I2 plus 12I2 minus 12I1 minus 2, because this 2 is incoming here. We are taking clockwise direction, but it is opposite to this direction. So you can take minus 2 equal to 0. So here you will get the value of Thevenin voltage. If you solve these two equations, you will get VTH equal to 22 volt. So here we can calculate maximum power equal to VTH square upon 4L, that will be equal to 22 square upon 4 into 9. If you solve this, you will get 13.44 watt. Here we have finished about maximum power transfer theorem. Now we can study about the source transformation. So here, if you see what we are saying about the source transformation, already we have studied about KCL, KVL, Thevenin, Norton, mesh, supermesh in our previous extra lecture. Now we are supposed to study about maximum power, which already studied just now. Now we are supposed to see about source transformation. So source transformation is nothing but we can convert Thevenin circuit into a voltage, Thevenin voltage circuit into a Norton circuit, or vice versa. मतलब हम क्या कर सकते हैं? By using the source transformation method, we can convert value of voltage into a value of current. How we can convert? If we are using the source transformation, at that time we are saying it is the process of replacing voltage source that is in series with the resistor into a current source that will be in parallel with the resistor, or we can convert the value of current source, the process in which we can convert current source where value of resistance is connected in parallel with that current source will convert into a voltage source where we will get the same value of resistance, but that resistance will be in series. So here what we can say, when we are having any linear complicated network, at that time we can convert that complicated network into a simple voltage source and a resistance source. That time that resistor will be in series with that voltage source. So we are saying that circuit as a Thevenin circuit. So if we are supposed to solve any complicated network, linear network, to derive Norton's theorem. How we can convert? We can convert that network into a simplified circuit where we will get the value of current and the value of same resistance. That resistance we are calling as a Thevenin resistance or a Norton's resistance. But that resistance will be in parallel. That resistance will be in parallel with that current source. So here we can see by using the source transformation, we can convert voltage source into a current source, और वी कैन कन्वर्ट वाइस वर्सा. हम वोल्टेज सोर्स को करंट सोर्स में कर सकते हैं या फिर करंट सोर्स को वोल्टेज सोर्स में कर सकते हैं. सो हियर if we are having the Thevenin circuit, what we are saying, in Thevenin circuit we will get the value of voltage and value of resistance that will be in series with that voltage source. Just wait for a minute, I am putting message to Namrata because he has not joined the audio. So he So here, if we are using the source transformation, what we are saying here, we can convert the value of voltage source into a current source and the value of resistance will be same, but that will be in parallel. Here, if you see, it is in series. So here we can see, if we are having the value of circuit in the form of voltage and resistance, we can say the value of voltage that will be V equal to, if you are applying KVL to this circuit, you will get V equal to I into R, voltage that will be across resistance, plus supplied voltage, given voltage that will be V of S. And if you are calculating this, how will you get? If you are deriving the equation in the form of I according to Ohm's law, what we are saying, Ohm's law states that we will get value of current in the form of I and R. So how will you get? If you are calculating the equations for voltage, you will get in the form of I and R. So if you are writing the equations in the form of I and V and R for the I, you will get I equal to V by R. That will be current flowing through this resistance minus Vs upon R, or you can say Is. You can say Is because we are taking here negative sign, because if you see here we will get the directions. If we are taking clockwise, you will get the opposite directions. That's why I have taken here negative sign. So here, if you draw the graph for voltage and current, if you are plotting voltage on x-axis and I on the y-axis, you will get plot looks like this. So here, we are saying we are converting here voltage source into a current source, or we are converting here current source into a voltage source. So here the arrow of current source, positive terminal of voltage source. It means what? If we are taking the directions by using the sign conventions. So we can take here, if it is a positive terminal voltage source, we can take it is as a positive. So here, if we are supposed to see about ideal voltage source and current source, at that time we can say there is an impossible source transformation when there is an ideal voltage source and a current source. It is not possible because We know if there is an ideal voltage source, we will get the value of resistance will be 0, or if there is an ideal current source, we will get the value of resistance that will be infinite. So we can say here there is a no possible source transformation for ideal voltage and ideal current source. So if we are having one example, like प्रियंका स्क्रीन दिख रहा है अच्छी से, आवाज आ रही है? हाँ.
Yes, ma'am.
Okay, so you can see here, if we are having any circuit and if we are supposed to find the value of Vx, you can see here we are having the value of current also. We are having the value of voltage here. So how we can find the value of Vx? We can convert that current source into a voltage source. How we can convert? If there is a current source and the value of resistance in parallel, you can draw here voltage source. How we can derive? According to Ohm's law, and the value of resistance will be in series. यहाँ पे पैरेलल में है तो वहां पे क्या हो जाएगा? सीरीज में आ जाएगा. So you can see here, if we are applying KVL to our first, if we are applying KVL around the loop in the figure B, if you see here, if you are applying here KVL, how will you get? You will get our equation like -3, because if we are taking the clockwise, plus 1 into I, plus 4 into I. So I have written here directly 5I, plus Vx, because we are taking from positive to negative clockwise, plus Vx plus 18, because it is also from positive to negative. But if you see this 3 is, if you are taking clockwise, it will be from minus negative to positive. So your first equation will become -3 plus 4I plus 5I plus Vx plus 18 equal to 0. So you can write in the minimization form like -3 plus 5I plus Vx plus 18 equal to 0. So here, how will you get these equations? If you see, we are supposed to find the value of voltage here. So if we are finding here the value of voltage at that time, if we are putting this circuit as an open circuit, your loop will become like this and you can apply KVL here. So now if you are applying KVL to the loop containing 3 volt, containing 3 volt voltage source and the value of resistance 1 ohm, means what? This circuit 3 volt and 1 ohm, and Vx yields, that Vx yields. So here, if you see, we will get here V equal to IR. So I will become V by R. So 3 by 1, that will be 3. So here, if you are converting this same diagram, but if you are converting that voltage source into a current source, तो हमें I का वैल्यू क्या मिल रहा है? 3 by 1, that will be 3 ampere. So you can write 3 ampere, that resistance will be in parallel, because here if you see, we are having the value as a 2 ohm. So here you can calculate, when you are applying KVL, you will get -3 plus 1I here, 1I plus Vx, that will be equal to 0. So if you are solving that equations, you will get Vx equal to 3 minus I. Just wait for a minute of some message. Wait. So here what we are saying, when we are applying KVL to this circuit, we will get this equation. And if you are applying KVL to only this circuit, kitna loop? Only you are taking this 3 volt, you are taking this 1 ohm, and if you are taking this Vx value, if we are taking this Vm, so your equation will become -3 plus 1I plus Vx equal to 0, and you will get the value of Vx, that will be equal to 3 into I. So here, if you are putting the value of this in our first equation, your first equation will become Vx का value यहाँ पे रखेंगे. कैसे रखेंगे? 3 minus I. So your equation will become -3 plus 18, that will be equal to 15. 5I am writing as it is. And Vx को मैं क्या लिख रही हूँ? 3 minus I. So your equation will become I equal to minus 4.5 ampere, and if you solve for Vx, you will get 3 minus I, that will be 3 minus minus 4.5, means 3 plus 4.5, that will be 7.5 volt. So here, if we are having one another circuit, and here now we are supposed to use the source transformation method, because if you see here, they have given compute the current flowing through this 4.7 kilo ohm resistor in the figure, and after transforming. So here we are supposed to transform 9 milliampere current source into a voltage source. How we can convert here? We know if there is a value of current given, we can convert that value in the voltage source, and that value resistance will be in series. And how will you calculate voltage? Here value of resistance is given, value of current is given, V equal to IR. So you will get 9 into 5, that will be 45 millivolt. So here you can see, if we are converting that value, that current source into a voltage source, we will get here value of voltage source, and here that resistance will be in series. So here our circuit will become 5 किलो ओम सीरीज में आ जाएगा, जो वोल्टेज हमने अभी डिराइव किया 45 वोल्ट, वो यहाँ पे वो रेजिस्टेंस को सीरीज में आएगा. How I am writing, you guys are supposed to understand the thing. I am converting that voltage current source into a voltage source. How we can convert? We are having the value of current, we are having the value of resistance. So V equal to IR, 9 into 5, 9 milliampere into 5. 9 into 5 is nothing but 45. That will be millivolt. And the 5 ohm jo resistance hai, kilo ohm, that will be in series. So I can write 45 volt 5 kilo ohm in series, and remaining circuit as it is. So now you can apply KVL. So if you are applying KVL, your equation will become minus 45 plus 5 into 10 raised to 3 into I, because it is the kilo ohm. So you can write 5000 into I, resistor into I. 4.7 kilo ohm, you can write 4700 I plus 3 kilo ohm, 3000 I plus 3 equal to 0. If you solve, you will get the value of current, that will be equal to 3.307 milliampere. Here we have finished about the source transformation. So there will be unit test on the electrical circuit on Friday, and there will be unit test for the electronic circuit on Thursday. I will share link on that day, and I will share assignment question today itself. I will share these notes also, PPTs, in our WhatsApp and classroom also. I am sharing our lectures daily, on daily basis in the classroom. You guys can watch there. Okay, thank you. You guys can leave now. So I am taking your attendance. So just wait for a minute. समझ में आया प्रियंका?
हाँ मैम.
हाँ, if you face any issue, you can ask me.
Okay.
हाँ, you guys can leave now. Thank you.